Today we're going to continue our discussion of basic electronic components. Today we are going to talk about inductors. An inductor is basically a coil. What it does is stores an electrical charge. It does that in the form of electromagnetic energy. A coil will act as a electromagnet that has electrical potential. It resists change. It does not like to change. If you run a DC current through an inductor, it will not change. It won't do anything. It just holds the electrical charge that's there. But if the current fluctuates, like in an alternating current, it resists that change. So it stores an electrical charge. What it does is creates a field. When charging, and then when the field collapse, field collapses when discharging. So you put a charge on the inductor. It'll hold that charge while the current is running through it. When you take off the charging current, the field will collapse and will induce a current flow through the inductor after the power has been removed from it. It creates the field when it charges, and then the field collapses when discharging. They are characterized by the inductance. Which is measured in henries. Big H. The unit is spelled with a little h, but the unit is a big H. Inductance range typically is between a few microhenries up to maybe 20 henries. So quite a broad range depending on the size of the coil. And they're also described by the number of turns. That is how many times the coil goes around. And they're also described by what is in the core. So a air core, just a coil of a wire around air, will have one inductance, whereas you put an iron core through that coil, it will have a different inductance. A iron core, for example, will have a much higher inductance than an air core. Now, a coil, an inductor that has a charge going through it, a constant voltage and current going through it, will generate an electromagnetic field. If the voltage fluctuates, it generates electromagnetic waves that propagate outward. This is part of what it makes a radio work. Electromagnetic waves are being sent out by the fluctuating voltage through the antenna and or an inductor. Which leads us to, what if you put two inductors in close proximity to each other? You get a transformer, also a passive device like the inductor. It is two or more coils in close proximity. When you fluctuate a electromagnetic field and you generate those waves that go outward, another conductor can receive them, and that induces a current flow in the receiver. That's the principle behind a transformer. An alternating current on one coil induces current flow in the other coils. Now, I said that they have to be in close proximity to each other. Most transformers, they're actually intertwined. They are kind of wrapped around the same core. Okay? But a common application nowadays is having two separate parts of the transformer in two different devices. You lay your cell phone on a wireless charging pad and you create a transformer with two inductance coils, one coil in your phone, one coil in the charger. The charger has a fluctuating signal, and that induces current in the cell phone, which in turn charges the battery. There's some other circuitry involved in all that sort of stuff, but basically what you're doing is making a transformer between your cell phone and the wireless charger. Now, if the turns if you have the same number of turns in both coils, it is an isolating transformer. I believe that's the term it's commonly used. Yeah, isolating or isolation transformer. It decouples the two circuits, so there's no direct current flow between two parts of a circuit, like the wireless charger and your cell phone. There's no actual electrical current being transferred from one to the other. It is just electromagnetic waves. If the input coil has a low number of turns and the output coil has a high number of turns, then this is going to be a step up transformer. If you have a current with, say, 12 volts coming in and your output coil has twice as many turns, the output will have 24 volts on it. It's receiving it has more area to receive the electromagnetic waves coming off the coil. So it will have a higher voltage, but a lower current. If for example, 12 volts at 2 amps here, and it's twice as many turns in the output coil, it'll have 24 volts and 1 amp. So there's a give and take. It doesn't amplify, but it does transform the voltage from one to another level. Likewise, if the input has a high turn and the output has a low turn count, it would be a step down. Those are the three types of transformers that you have. Yeah, that's basically about it. I mean, there's some equations and stuff like that to learn in circuits and electronics and all that sort of stuff class, all those sort of classes that tell you how to calculate the gain, not the gain, but the levels in and out of a transformer, different types of transformers with multiple coils, that sort of thing. But it is a passive device. It does not actually amplify any power. It will actually use power. All right, so the next basic component I didn't cover this in the last time I taught this class, but I thought I'd go for it this time around. Oh, I'm sorry, I forgot something. Inductors. That's the symbol for an inductor. It looks like a coil because that's what it is. And transformers are two coils with typically some sort of core and with the input and output coils. So they have a minimum of 4 connectors. So should make sure that was put out there. Switches. Also a passive device. They don't produce energy. They don't amplify a signal. None of that stuff. They are characterized by poles and throws. A pole is the number of connections that you can have, or how many options there are. The throws are how many copies are connected to the same mechanical switch. So a switch, just one connector, and it connects one wire. It would be an SPST, single pole, single throw.
Could you repeat what a pole was?
How many an option for the connection. So I was going to get to more examples here in just a second. If you have two options, see, this one is either open or closed. That's just it's either connected or not connected. Here you have two poles it's either going to be one or the other pole is the connection. So that would be a double pole, single throw. Now you can have single pole double throw, where you have effectively two switches in parallel connected to the same mechanical device. Flip the switch and it connects two separate wires. But still, there's only one option, either this set of wires or no connection at all. I'm sorry? No, this would be still one pole, considered one pole. There's only one option for the two connected switches. Then you have buttons. You have two different types of buttons, the normally open and normally closed. The normally open button, when it's just sitting there, has no connection. Whereas the normally closed, but if you press it, it makes the connection. Normally closed, just sitting there, there is a connection. You press the button and it opens the connection. It disconnects the two wires coming in. I think that'll be it for today. Wednesday we will cover transistors. Next Wednesday will be the midterm. It will be comprehensive.